Okay, ladies and gentlemen, example 4. Factor each difference of squares. Check your answer by expanding. Okay, so factor. Factor means take something and break it up into its factors, its multiples, if you will. So we're going to take a squared minus b squared, and we're going to break it up into two things being multiplied together, a minus b and a plus b. Excuse me. So, now remember, it doesn't matter whether you have a plus b first and a minus b second. What matters is that you have the first term first, the second term second, and separated by opposite operations of addition and subtraction. Now, factor each difference of squares. So it's going to be in this form. If it's not in this form, then we're not factoring difference of squares. We're doing something else. All right, check your answer by expanding. So we're going to factor first, and then we're going to expand it to come back to the original expression. Okay, so this is the way I do these questions. I take a look at x squared and I write it as x squared. I take a look at 36 and I say to myself, okay, what number multiplies by itself twice to give 36? I can use my calculator, 36, second function square root, and the answer is 6. So it's going to be 6 squared. This is now in the difference of squares form. The first term is x, the second term is 6. The first term is x, the second term is 6. I separate them by different operations. One's positive, one's negative. I then take a look at this and see, can I factor any further? The answer is no. There is no factoring any further. I can't take anything out of this one. And this is no longer a difference of squares. The x is not a square. The 6 is not a perfect square. So I'm done. To do your check, what you do is you take your answer and you expand it. X times x is x squared. Negative 6x. Positive 6x. Negative 36. Remember, a positive times a negative gives us a negative. So this is going to be x squared minus 36. And that, if it's the same as what we started with, means that what we did was correct. All right, let's look at the next one. 9 minus x squared. A little bit different. Well, 9 is a perfect square, and so is x squared. So it's going to be written as 3 minus x and 3 plus x. That is the answer. That is factored. We check it by expanding. 3 times 3 is 9. 3 times x is 3x. Negative x times 3 is negative 3x. And negative x squared. And it is what we started with, so we are correct. Next one. Oh, we take a look. Can we factor any further? The answer is no. This one, 16 and 81. Well, it's a little bit trickier to make these a difference of squares, but it is a difference of squares. 16, if I use my calculator, is 4, so it's going to be 4x squared. So the 4 squared is 16, and the x squared is x squared. The 81 is a difference of squares. 81 square rooted is 9. So it's going to be 9 squared. All I did was rewrite it. I haven't factored it yet. Factoring it will look like this. 4x minus 9 and 4x plus 9. Can we factor any farther? This is not a difference of squares. 4x. X is not a perfect square, so I'm done. This is the sum of squares. It's not a perfect square. There's nothing common that can come out of them. We should be done. Let's check to see if we're right. 4x times 4x is 16x squared. 4x times 9. 4 times 9, 36. Minus 36, minus 81. Our answer is the same as above. We are correct. And let's take a look at this one. 4x squared minus 1. Well, 2x squared minus 1 squared. And that's a bit of a trick. We got to remember that 1 is a perfect square. If I take 1 and square it, I still get 1. So it'll be 2x minus 1 and 2x plus 1. Let's expand and see if we're right. 2x times 2x is 4x squared. 2x times 1 is 2x minus 2x minus 1. we end up with 4x squared minus 1, which is what we started with, which means we are correct.